Well, all right. The Wells Fargo wagon stopped at the corner and dropped off this package. Crazy what just happened. And we're going to pretend like I hadn't opened the box, and I'm going to open it up and see what's inside. Could it possibly be stuff from Mauser? Is it possible? Could it possibly be capacitors? I doubt it. It is. They are. Package from Mauser. I had ordered them on Sunday. Today's Wednesday. I did a 2-day expedited shipping, and super impressed that it was actually expedited, and it just got here today. I ordered a few other things for other projects. Some 2.2 meg resistors, replacement cap for possibly for something in this Zenith chassis, 680 picofarad caps. Use these to build integrators. I use them all up on the black and white set before. These are the .0039 caps. All right, good. And then in here is something special, so special that it had to be wrapped up in special stuff. What is it? What does it say? It says, yeah, or .039. Now, I don't understand why. I don't know. Let's see. What? Oh, that's why they're not wrapped in a plastic bag. That's the trick. Okay, so what do we have here? Capacitors. I ordered more than we need. Why did I order this many? Well, 4, 8, 10. Okay. I ordered 10 of those. Why? I don't. And I ordered, I don't know, 5 of these. I got a little carried away. It almost feels like if you're going to place an order, but we're all set to go. Capacitors. Yeah, I was just putting the packaging away. Look at this. Priority. Second day. This is the best reason to use Mauser, because they send it to you in a box, and you take the top of the box off, and then you got a box to put your parts in. Look at this. All right. That's the reason to shop Mauser. Welcome back to part 2. Just as a note, first off, if you use one of these meters for reading cathode current, be aware that inside of it is a fuse. These are 1/2 amp fuses, and they are not necessarily robust. So I was just making an adjustment on the high voltage, and just a transient, whatever went through the system was enough to blow the fuse and shuts the whole set down because your cathode is interrupted from your horizontal output. So at first it really confused me. I didn't know what had happened, but it was the cathode current meter had just blown its fuse. So yeah, this right inside, just like this. I put something else in here. I don't even know what the value is. That's all I had. And I don't think I would recommend bypassing the fuse. That seems a little bit not right. So anyway, beware of the fuse. Well, our first order of business is this pin 6 of our vertical output. We're going to clip on our scope probe to pin 6 and see if we have this waveform there. That's where we'll start before we put the new capacitors in there. We'll see what it was and what it becomes after the cap gets replaced. So pin 6, we're going to use one of these, well, it's a Compactron tube extender. And I've marked pin 6 right there, so we can clip on our scope. We're going to use the Sencor Megascope and clip the probes on, and we'll see what we get first off. That's a good place to start. So let's go over here and see. This is our vertical multi-vibrator and output tube. What is it, a 6 ME8? Oh, I guess it doesn't matter, but let's look at it. A 6MF8. It's an MFer. And so we're going to take that tube out, put the extender underneath it, and put the whole thing back into the set. Yeah, let's grab our tube out of here. All right, here we go. It's a big one. Stay. 2 hands required. All right, there we go. So this is going to go in there, and unfortunately it looks like pin 6 is going to take us all the way to the back. So let me see what kind of tight fit in here. All right. All right, so we have our tube in there. Sure is not a good fit. I don't think it was designed to be done like this. But you can see back there is our pin 6 right there. So let's see what we can do here. And by the way, this Sencor scope is a very interesting scope. Of course, it's old and needs a lot of work, but these Sencor probes, these were unique to Sencor scopes. And this lead that comes out is the voltage reading. Plugs right in. That's where the DC volts goes into the scope. And this digital readout, and they were prone to failure. This digital readout, it makes this scope super handy. Super handy. So we're gonna get in here somehow and clip this on. Definitely tight quarters. So here we are. And I don't know about our scope. That's all noise that's being generated inside of the scope. I don't know. We might have to go to plan B on the scope. Onage. All right. Firing up. So we have our, look at that, we have our vertical waveform over there on the Megascope. And we've got our cathode current coming up, just like it's supposed to. 200 right there. All looking good. We have a kind of a nice looking yet noisy waveform. Yep. So we have a raster, but where is this noise coming from? It isn't because there's nothing on the antenna terminals. I wonder if that noise is just coming from the scope. This scope has got, oh, look at this. Wah, wah, wah. Collapsed wave, horizontal sweep. There we go. We gotta fix this next. All right. What does our raster look like? We still have this weird noise. Let's disconnect our scope. Oh, let's just do it right here. Let's see if that changes the noise in the picture. No. We have a garbagey looking, noisy raster. Okay. Don't know. But let's look at this. The good news. What's the good news? Well, the waveform looks pretty good, the vertical waveform. The bad news is this scope needs a lot of work. We have a basically 0 volts right here at pin 6. And pin 6 wants to be 0 volts. So that's correct. So we're gonna, before we flip it over, let's just throw a signal into it and see what kind of picture we get. I don't know. All right. Testing. Oh, what's our current like? Yeah, it's good. Just where it should be. 2 amps. Okay. All right. Let's throw a picture on it. Well, all right. We have replaced the Megascope with another aging piece of Sencor gear. This is the VA48, and it's a signal generator. It does a lot of things. It's really pretty fantastic, but this also had to be fixed. I'll take this chopstick and just bump that connection there and take a look and see what happens. There we go. So it's definitely a it's a solder joint right there at that base of that connector. So I'm going to get it there. Any of this stuff from the 80s is going to be, or early 80s is going to be problematic. So anyway, right now we just have it on color bars and channel 4. So let's see what we get. Onage. Channel 4. So this is more or less a baseline, I guess. We just want to kind of see what the set does. Does it work? Is it... We know it works, but is it messed up? What do we have to do to make this set better while we're inside of it? Feeling our way around the guts. So we should have color bars coming up, and we do. And to the eye, the picture's okay. This wavy noise isn't nearly as pronounced to me as it is on the camera. This is our hue control and our color control. I think these pots are in rough shape. They need to be cleaned and lubricated again. Tuner works. For fun, let's try a different channel. Let's go to channel 8. Channel 8. Yeah, that's channel 8. Fine tuning is way off. Oh my goodness. Oh my goodness. Uh-oh. There we go. That's the peculiar thing about some of these vintage sets. Some channels work better than others. The tuner works better on some channels than the other. And this particular tuner, I spent a lot of time fooling around with sort of the mechanics inside of it. It was kind of rough shape. So this is really good. We have color. We have a reasonably stable picture. Let's look at... this is our bar suite. So this is a representation of all of the frequencies that the set should be able to reproduce. And it looks pretty good. There's convergence issues, bendy lines, but this set kind of always had bendy lines. So that's good. Let's look at our crosshatch pattern. Yes. All right. So it's all pretty good. There's nothing wrong with it. That ghosting is maybe Yeah, you know, it just is what it is. It's television. So, all right, well, all right, so I would say we have a set in decent shape. Yeah. We're going to replace those two capacitors in the vertical circuit, the 0.039 and the 0.0039. It'll be interesting. We'll try to remove them so that we can still test them. It'd be interesting to see where they're at. They're dripping wax. So that's our first order of business. So I'm gonna turn it off. We're gonna flip it up on its face, and we're gonna get at it. But today is March 15th, middle of the month, and spring is full on upon us. We are in southeastern North Carolina, and I can't believe that the pollen is at this level at this time of the year. It's like there was a sinus bomb that went off in my head. So anyway, see if I can get a little relief just being around it. This is no joke. This is pollen washing down the gutter. River of pollen. All right, here we are, back at the bottom again. And our goal is this one and this one. Possibly this one. This one's got some funny business also, and this is part of the vertical circuit. But we'll start with this one, and then we'll do this one, and turn the set on and see how it works. I'm not sure if I really believe there's going to be much of a difference, but it's going to be super interesting to see what the values, the current values of these capacitors are. And I've got to try to snip this out and maintain enough lead that we can solder onto it, but also enough lead that we can get the tester on this. I have to see what it's become, unless it's still what it's supposed to be. But these are 10% capacitors. That one, that one, that one. And I'm not sure if this is in the vertical or the horizontal circuit. I'll look and see. But in any case, 10% capacitors, they don't have to move very far in their value before they're valueless. All right, so I'm going to try to get in here with the idea to leave just enough lead to test it and enough lead to solder onto. 1, 2, 3, because we can't go back. Found it. Look at that. That's ugly. Yes, enough lead that we can solder on a lead and test it. Okay, unfortunately, I don't know if I have enough lead on this one here, pin 6, to solder onto. Maybe. These are really tough to unsolder, these connections. And by the way, look what's being delivered across the street. Yeah. So I think we're going to close the shop doors, avoid this pollen, work in a quieter space, and we'll test this. Let's get this, I'm curious about this, what this value is. And I think we have enough room. It's going to be a tight one. This one, yes. This one, that's the lead we have to solder onto. We probably have enough. Unsoldering from this tube socket is, it just destroys these things. So, all right, let's try it. Testing. Yeah, okay, so it's just over 10%, so, well, we'll change it anyway. But good to know. We learned something. And 10% of it would be close to 42,000. So this is just over 10% going up in value. So this was actually fine, but we're going to replace it. That one. And then so we finish this, do this, and we'll spark it up, see what we get. Hey, let's use this one. Take it from our goodie box. This came all the way from Mouser. Let's use it. All right. See how nice this parts box is? You can store all kinds of things. Maybe we even store this for later, because I think we're gonna need one of those. All right, so why would a new part be bad? Why in the world would you ever test it? I don't know. Testing. Right on the money. 0.039 microfarads, or 39,860 picofarads. One down. I mean, it's not the prettiest solder thing in the world. Very short lead, made a little hook best I could, put some solder on it so it'll be okay. It's not too close to ground or anything, so it's all right. And we'll get at, where are we gonna get at? This one. I bet we'll find that this one's okay also. And because of that, I don't know, maybe we won't even bother here. But let's see what this one is first, and we'll take a look and see what this is. Does that say 1,000 volts on it? Okay, that came out 0.0039 at, I think these are 400 volters. That's what I bought anyway. Boy, we're having a hard time reading these things today, aren't we? Let me check what the voltage is on this capacitors. See. Golly, I can't read much today. Is that pollen in the air? C90. Okay. Let me look and see what C90 is. All right, 0.0039. Place your bets. Place your bets. What do you think? What do you think? Oh, 3,600 picofarads. So it's gone down in value. It's gone down 390. Yeah, it's right there on the lower end of 10%. Alrighty, so that's our goal, is to get a 3,900 picofarad cap in there. So, all right, let me show you something that I just saw. Okay, so I just looked at the parts list again, and that cap, this one, 0.0039, it's hard to read the voltage on it right there. Well, it's cap C90 from the SAMs, 0.0039. It's a 600 volt cap at 10%. I don't know if you can see it, but I bought 400 volt caps. Wah, 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 rookie mistake. So we're gonna quadruple them up like that, and we'll get an 800 volt cap. What a loser. I can't believe I made that mistake in my haste to just order parts. Let me see if I can get at this, the top of this, and just double check. Yep, so with ye old magnifying loupe, that number on top is 400 volts, 3 and 9 at 400 volts. So, good thing I ordered enough of these bad boys. So I did this. I have them in series and in parallel. So we should get approximately a 3900 picofarad capacitor. And since these are 400 volt caps, this should handle the equivalent of 800 volts. So that's fine. And doing a little testing, that's about right. Most of these capacitors were testing around 3750 picofarads. So, and 10% down from 3900 would be something like 3550, something like that. So this is well within the 10% tolerance. So rookie mistake, but it'll be fine. No one's ever gonna know. Okay, let's put it in. That's the next question, isn't it? About. Well, it's in, and 0.0039 microfarads at 800 volts now. And in case you're wondering what I did, aside from just making a mistake when I ordered them, if you put two capacitors of equal value in series, you get half of the value and twice the voltage handling capabilities. And if you put them in parallel against each other like that, you get double it. So by putting two in series, I get half the value at 800 volts. And then by putting two of those clusters in parallel, we get the restored value of 3750 picofarads at 800 volts. So it's kind of bush leaguey, but should work fine. Yeah, all right. Well, I just lifted this from the circuit. It's in the vertical circuit also. It is a 0.0047, and great. That's totally within the 10% tolerance. So this capacitor should be 4700 picofarads. It's 4900 picofarads, and I think 10% would be over 5,000. So we're good. I'm gonna just hook it back into the circuit, and I'm gonna just leave the rest of these alone. We're not seeing anything grossly out. I'm gonna solder this back in, and we'll flip the set over and see how it starts up and how it behaves. Well, I put the parts back together, and I put the horizontal output tube back in, and isolation transformer, cathode current meter, everything should be good to go. Got the signal generator set for color bars. So we just want to see if it works, first of all. Something's happening. There we go. Color bars. Not bad. Okay. These are the bar sweep patterns. The color killer works. I'll show you how we can tell. When we switch into the bar sweep pattern, look right here, there'll be some color to it, and then it'll fade away or go away pretty quickly. Color, and then it goes right away. So that means it's operating properly, the color killer circuit. Not that we really need it anymore today, but that looks pretty good. Dots. So these are our crosshatch patterns. Convergence is off. Linearity is off. So we're going to fool around with that a little bit, and yeah, adjust the convergence. So we'll work on the linearity. We did change a couple of capacitors in the vertical circuit, so it wouldn't surprise me that it's off a little bit. I don't think we had perfect linearity, but I think it was better than this, but I mean, it's okay. I don't know what to expect with the set, really. There's convergence issues up here all the way around, and this set has consistently had a drifting convergence. I never really figured that one out either. So still a lot to go with this. And there's the single cross. Now in the dark areas here, I don't know if you can see it. Well, it's kind of in that moire pattern. But there's noise in here that I can see. And I'm just not really sure what to think about that. So anyway, the good news is that so far so good, and our cathode current is right there at 200 milliamps. So we got that going for us. All right, well, I'm going to shut it down and go to the next thing on the list, which I don't know what it is. I don't know if you can see this either. There's like a pattern of something that's moving through the image, and I didn't see it on the crosshatch. Not at all, but I see it on the color bars. And the idea of getting into whole color alignment is, well, maybe I need to look at that, but I don't want to jump into that or jump to that conclusion before it's time. And I still do have the tube extender in here on the vertical circuit, so maybe we'll get Megascope out here and take a look at it again. Maybe we should just do that. Okay, I'm going to shut this down, and I thought we'd take a quick look at the vertical waveform before we did anything else. And you can see our probe. You can't see very well, but our probe is attached to pin 6 of the vertical tube, and we're just going to snap it on. I believe I have nothing attached to the antenna terminals. Well, it's disconnected on one side, so there's no signal going into it. This should just be the raw raster. And the scan rate of the camera makes it kind of difficult to see it on this scope. But as this warms up, we have cathode, we have high voltage. I can hear it. Oh yeah, high voltage. How's our vertical looking? You know, actually, the vertical waveform looks pretty healthy. It's really hard to see it, unfortunately, with this camera and the scan rate of the oscilloscope. It's hard to see it, but this actually is a pretty strong looking vertical waveform. So I think we're going to call this good. We have, those are our peak-to-peak volts, 40 volts peak-to-peak. We should have almost 0 volts here. Yeah, and then our frequency is just a free running oscillator right now, so it's way wrong in that respect. So actually, let me put a signal into it now. Let's see what happens. All right, so we have color bars going into the set, and yeah, once again, it's really hard to see it, but that's an excellent looking waveform. And well, I don't know, our scan frequency doesn't seem right, but our picture is not rolling. To the eye, it's fine. So there we go. I darkened the shop here so you can get a better look at the vertical waveform. So yeah, looks pretty good. I've been pondering this for years. Well, we should have PBS coming up. Usually there's a bright, colorful picture. High voltage is coming up right now. All right. Brightness is coming back. All right. Well, I'm going to turn the sound down. We do have sound. And we have our cathode current is right there at 200 milliamps. And if we drive the brightness up, really well, this is all the way up. I've got the brightness range set so that it won't drive it too far past maximum current on that output tube. And our contrast is somewhere in the middle, I'd say. Let's look and see here. Oh gosh, yes, somewhere in the middle. So the picture looks pretty good, except for something that I just noticed. And I'll show it to you. There's a couple of things. One is that, as a general statement, the hue control is not in the middle, and that is another exercise to track down. But I think what I am looking at, let me see if I am correct. Take a look at the right side of the picture as I push down on this phenolic strip. Yep. You will notice that the color comes in. So there's a strange effect when I release the pressure on this piece. We lose some of our hue on the right side of the picture. Now, this is not necessarily a new problem. A couple of years ago I was fighting it where the right side of the picture was completely black and white. And we'll get into this. I'll show you what I found. But I can make this happen pretty reliably by doing this. So what I am doing is I am pushing on a phenolic strip that has a solder cone, a series of solder cones on it. And I am using this, which is a non-conductive, it's a chopstick from the grocery store. One of the best tools. But there's something in this region of this of the circuitry. I fought this a while back, and I thought I had figured it out, but it's come back. So I'm going to push on it again and take a look at the right side of the picture. Beautiful. Even get an increase in our brightness. So if I turn the brightness down and I turn the contrast down a little bit, I mean, that's a really nice picture right there, except for the horrible convergence. That's another thing. It is a bit cold out here, so that's another conversation to have. So as I release the pressure on this, we lose that color and the brightness changes. So I'm not sure at this point. I've been in this part of the set so many times. And, so I just saw an arc. I still have the glass rectifier tube in. It's probably why it took so long to warm up. So, all right, yep, it still does it. Okay, so I'm going to snap the set off, and what we're going to have to do is lay this on its side, rectifier side up, and so we have access to the bottom, and yet we can still see the picture. When we lay it on its face, that's about all we have. So, okay. Well, that phenolic strip in the middle is the one that we were pushing on. That's very sensitive to pressure. And on the other side of that is this cluster of components. And let me get in here and show you something. So oddly, that solder cone right there in the middle is the one that we were pushing on. And there aren't any wires in it because the wires that used to be in it are right there. Now that was the solution that I came up with a couple of years ago when I was having problems with the right side of the picture going completely black and white. It is my opinion that there's so much flux that leaks out of these solder cones when you try to resolder them that this phenolic strip became conductive or capacitive. And I found that if I traced it all the way down to that particular solder cone, and if I took the leads out and grouped them together outside of that solder cone, the whole system worked fine. But as soon as I put them back in to that point, I had the problem again. So I figured it was something like capacitance or conductance. Now you might also see right in here, there's some plastic. So I inserted some plastic around the edge of that phenolic strip, thinking that it might serve as an insulator. It seemed like everything worked fine. It worked fine for a couple of years now, year and a half. And the problem seems to have come back to a certain degree. I've got it on its side, and did I connect? Yep, I connected the source power. We've got power to the set. We've got a signal coming from our ATSC box. Nothing is stopping us but fear itself. Let me turn the volume up a little bit. We're on channel, I think, 8, because the knob is not present. Not yet. Let's see what happens. Warming up.
8 on PBS-NC.
Okay.
You're watching North Carolina's
We have sound. Turn the sound down. Hope we didn't get any copyright strike. I took out the cathode current meter, so we don't have any. All we have is the picture. Okay. Well, our color is wrong. Way wrong. Way wrong. Gosh, I don't even know what to make of that. It's so far off. But let's look and see if, I think that looks pretty good, what I did. Let me push on the problem area and see if something changes. But I think it's good. Well, we have the color bars up now. This is now tomorrow, and I had kind of let it sit like this overnight. You saw the Q-tips that I had used with the acetone, and I cleaned up the phenolic strips. I'll show you what it looks like. It's a little bit much cleaner actually than it was. And before I shut it down last night, I thought I had noticed that the problem had pretty much gone away, and it seems to be the case. Maybe in fact all that flux and junk on that phenolic strip and around those solder cones really did make the difference. So I cleaned it up. I'll show you what it looks like. And it doesn't seem to be sensitive like it was before. Now there's still a few things here in the color bars. I think this is the shadow mask that needs demagnetizing. So we won't do that until we lay the set flat again and get it closer to being buttoned up. I'm still a little concerned about the hue control not really falling in the right place. I noticed that there, in the SAMs and the Zenith manuals, there's a somewhat extensive color amplifier adjustment procedure. And I don't think we're going to get at it in this particular video. I think I may just end up putting the set back together. It's looking pretty good. I can see things that don't seem right, but it's looking pretty good. And just use it for a while, and if something fails, we can use that situation as clues. I fooled around with the convergence, and I found areas in the back of the set around the convergence clover that were super sensitive. And like you do with vintage TVs, you just sort of jiggle wires and tap on things lightly, and sometimes it just makes it all go away. And at this point, the convergence looks fantastic. It doesn't normally look this good. So maybe we quit while we're ahead for now. That's kind of where I was going with all this. It was St. Patty's Day the other day. I think somebody sent me a St. Patrick's Day gift. This is the part on a TV project where you start throwing money at it. Everybody does it when you get into it. You throw money at it. Amazing. Upwards of 90. This is about what you'd expect. However, what I didn't, it's not going to be a problem, but what I didn't even know was that 6 LF6s have 2 different heights. So there's plenty of lead from the plate cap to put it on here, but the problem would be that this support device up here would be too far above the actual tube. So maybe because it's shorter, I don't need the support. Well, let that be a lesson to me and everybody else. 2 different heights on 6 LF6 tubes. And come to think of it, I did remember seeing a listing for a tall boy. I guess that would have been not a beer, but a taller tube like that. We have our new horizontal output tube in, and we have our high voltage probe under the cap, and we have our current cathode current meter reinstated. So we're going to take a look at what this new output tube does. I'm going to snap it on, and well, let me put it on color bars, so it'll start up into color bars, and we'll keep an eye on the current and the high voltage. I would expect it to be higher, so we might have to, and I have an adjustment device in the high voltage adjustment pot too. Alright, so our cathode current is right around 200, a little bit under, and our high voltage is 22,000. I'm going to back that down just a skosh. maybe a skosh more. All right, what I realized we need to do first is we need to take a look at our white balance. So I'm going to go into the service position, and I'm going to bring up our red line, very dim. Bring up our green line. I have a nice yellow line now, and I'm going to bring up our blue. So that's going to be the base of our white point. And Zenith recommends this is where you set your high voltage. And it looks pretty good. Double check it. And let's go back into service and normal. From service to normal. And I adjusted the brightness range. So when I have the brightness up full drive, it's just a little bit over 200 milliamps. So there's a great range of brightness. And our high voltage is right where it should be. So let's take a look at what kind of a signal we have here. Color bars. Color bars look pretty fantastic, actually. So I think what I'm going to do is going to turn the set off, remove the metering equipment, because I feel very satisfied with the high voltage and the cathode current. All right. Snap off the set. I'm going to have to let the horizontal output tube cool off. It's pretty warm. And then we'll take a look at our purity and our convergence and those other functions. On edge. And we're going to see what we get. We are going to come up into, let's come up into just a blank raster. We're on channel 8. And then from there, we'll check color bars again, and we're going to look at our crosshatch pattern, tinker a little bit with our vertical linearity, check our convergence, do a little purity setup. All right, so we now have a blank raster. We should see a bar sweep pattern here, and the color killer works, so that's pretty good. It looks pretty good. And color bars. And look at our hue control, it's pretty much in the middle. Yep. Dots. Crosshatch pattern, it's excellent. I don't think I'm going to mess with that, because from messing with it in the past, I know how good it can be, and this is pretty good. But let's take a look at our, first of all, let's look at our single cross. This is our center point. This is where we would set our static convergence. And maybe the blue vertical is out a tiny bit, so let's just look at that. This is where you don't want to stick your fingers, not necessarily. That looks, yeah, wow, good. And let's go back to our dot. Great. Crosshatch. How is that possible? Dots, pretty good. Color bars. Yeah, how about that? I just think it's pretty, and the hue control is right in the middle. So whatever we did before with adjusting that slug seems to have really made a difference. We have our bar sweep pattern. So in a pattern like this, or a black and white movie, if we didn't like the tonal range of the black and white, we would make an adjustment at this point. So as an example, we set our high points, our whites, with our G2 screen drives. So there's a green, a red, and a blue G2 drive. And then there's also the G1 screen attenuators. So in this particular case, I'm going to turn the green all the way down and turn the blue all the way down, so we get predominantly a reddish tint to it. And because the red cathode doesn't have an attenuator in line with it, it's driven directly off of the video signal. So what we're going to do is bring up our blue and our green drives, G1s, to kind of find what would look best as a neutral, well, black, I guess. It's pretty good. I mean, it's subjective. It's super, super subjective. I'd say that's pretty good. And those controls are accessible through the back of the cabinet, so you can tinker with it later. So we're going to call this pretty good. And I just randomly have the brightness at a point. I can bring it up, open up the shadows a little bit more, and the contrast is right about in the middle. So this is pretty much a solid test image. Back to color bars. Looks great. Looks great. Okay, so what are we going to do with our crosshatch? Let's just take a peek one more time at the linearity and the size of the vertical. I'm going to not beat this one, and maybe I shouldn't touch it at all, because we've already tried this. I'm going to leave it alone. I think those controls are also accessible from the back of the cabinet, so get it all back together and get it operational, and then we can so we'll look at our purity right now. We're going to sort of cancel out a lot of this hard work we just did, and we're going to turn our blue G2 down and our green G2 down all the way, so we have just a red picture. I'm going to bring it up, and it is this red signal that we use to check the purity, and the purity looks pretty darn good. So I think what we're going to do is not mess with it, because it looks pretty good. So in order to go back to our white balance setting, go back into the service position, bring it up slowly till we have a red line. Come on, red line. There we go. And bring our green up so we have a yellow line. Come on, green line. Quite a ways up. Oop. That's our yellow line, and here's our blue drive coming up, G2, to form a white line. A white line, man, that sounds like a song. What was that Hetty song about her love being better than a white line? You guys know what I'm talking about. Okay, so that's it. The purity was great. Sorry we didn't adjust it. So let's double check our color bars, and let's put a picture on it and enjoy this. But I think we're going to put the cover back on and let it run for a while. I may have to, I'm not sure what to do with the glass rectifier, high voltage rectifier tube. It generates a ton of heat, and I had gone to a stick rectifier before because I was just trying to keep it all cool. But maybe we just leave it like this. I'll have to take a little bit of the structure apart to get the door back on. There's probably some X-ray radiation, some X-rays that are coming out of that, and that's the reason why, one of the reasons why you have a high voltage cage. So maybe we'll do that. But those color bars look amazing. Okay, I'm going to just stop saying that. Okay, we're going to turn this off and go to the next thing. Putting the cover back on ye old 1970 Zenith. This really is a beauty. Zenith has built this cover, this cabinet, to really isolate the user from any kind of contact with metal chassis. I mean, aside from it just being absolutely a safety thing, they just did a really good job at doing it. That's my 2 cents on this. And making sure the holes line up. Yes, they do. Product of Zenith Radio Corporation, Chicago, Illinois, USA. They were giants in their days. Wow, okay. So this is a 1970 Zenith color portable set, model A3720. Hot chassis set. I don't even know what to say. I am so happy with the way it works now. And I'm not even really sure what we did. We fixed the high voltage. We tinkered with some of the other things. But now I've got to get back to watching that episode of Columbo that I fell asleep watching. Can't fall asleep, though. One last comment. We replaced the horizontal output tube and the high voltage rectifier. So we have a glass high voltage rectifier the way it was designed to be used. And we have a new old stock 6LF6 horizontal output tube. And that really made a big difference. I'm very surprised. I kind of didn't expect it to make much of a difference, but it seems to have a lot more punch to it. There seems to be more range, brighter picture at the same current. So there is a lot to be said about a failing or fading or aging horizontal output tube. So I'll keep an eye on this and report back, but I think it's great.
Race to the seat of the master controls.
All right, Jones, what's on your mind?
You'll find out soon enough.